Hello everyone, welcome to my channel Education for Aspirants. Today we will discuss how to design a NFA for the language L equals to W belongs to 0 1 star such that the number of ones in W is even. Means the language will satisfy all the strings where the total number of ones present inside the string is even. But it is not mentioned how many number of zeros will present inside the string. Clear? Now for this language, if we will design the strings which are acceptable to it, we can write that is 1 1 1 0 1 1 1 0 1 1 0 0. Clear? Because here see total number of ones present 2, but number of zeros is 3. It is not mentioned how many zeros will present. Similarly, we can write 1 0 1 1 0 1. Clear? So these are the strings which is satisfied to this language, because here in this string, so total number of ones present is even. Clear? Now we will decide which are the strings which will not satisfy to this language. Means in the string, if the total number of ones is odd, it will not satisfy. So for example, let single one, because here number of ones is odd. 0 1, it is also odd. Then 1 0 1 1 1 0 1 1 0 1 0 1, that is also not satisfied because here total number of ones are odd. Clear? Then we can write 0 1 1 1, that is also not satisfied. These are the strings which are not satisfied to the language. Okay, so I hope you understood what are the strings which will satisfy to this language and which are the strings not satisfied to the language. Now we will move to design the NFA for the strings which are satisfied to the language. So these are the set of strings which are satisfied to our language. So to design the NFA, our first duty is to choose the minimum length string. Here what is the minimum length string? That 2 ones, right? So the minimum length string is 1 1. Now we will decide to design this string how many states required. So the rule is total number of characters present inside the string plus 1. So here total number of characters present 2 plus 1, that is 3 states required to design the NFA for 1 1. If 3 states required, then our Q will become Q0, Q1, Q2. Q2 will become our final state. Okay. Inputs required 0 and 1, right? So we'll write sigma equal to 0 and 1. Clear? Now by taking this information, we will design the NFA. So first we'll take the initial state as Q0. Then on Q0, by reading 1 as input, it will move to Q1 state. Similarly, on Q1, by reading 1 as input, it will move to Q2. And Q2 is our final state. So this is the diagram for satisfying 1 1. Now we will expand the diagram to satisfy all the different type of strings where the number of ones will become even. For example, let us consider the string. It may be 0 0 0 1 1 0 1 1. Clear? 0 0 1 1. I mean to say here any number of zeros present before the even number of ones. Clear? To satisfy such type of strings, we will take a self loop on Q0 by reading the input 0. So it will satisfy any number of zeros followed by 2 ones, right? Now we will decide the strings. For example, let 1 1 0 0 1 1 0 0 0. Clear? 0 0 1 1 0 0. Clear? Means any number of zeros after the even number of ones. So here this is our final state. Okay, here in this state we are reaching with a even number of ones, right? And after this, how many zeros are present, we don't know. This means to satisfy these strings, what we will do, we will take a self loop on Q2 by reading the input 0, so that it will help you to read any number of zeros after even number of ones. Clear? Now we'll decide if the string will read any number of zeros in between means the even number of ones. For example, 1 0 0 1. 0 1 0 0 0 1, clear? Or we can read 0 0 1 0 0 0 1, clear? Means how will you represent the total number of zeros present in between two ones? So to represent such type of string, what we will do? We will take a loop on Q1 by reading 0 as input, so that it will help you to read any number of zeros in between these two ones. Clear? Now we'll decide, for example, let the string may be 0 1 1 0 1 1. Here total number of ones are 4. Similarly 0 1 1 1 0 1. Here also total number of ones are 4. Then 1 0 1 1 1 0 1 1. Here total number of ones are 6. Means if such type of string is there, then how will you satisfy? You know that in this diagram you can reach on Q2 by reading 2 ones. But if you require to read more number of ones, for this what you will do? From Q2, if you will make a transition from Q2 to Q1 with the input 1, then it will help you to read even number of ones inside the diagram. How? Because from Q0 to Q1 first one, Q1 to Q2 second one, then Q2 to Q1 third one, again Q1 to Q2 fourth one, means you are reaching at the final state, right? Now this is our final figure, so we will design the transition table for this. So inside the NFA, 3 states are there, so we will take 3 states here, Q0, Q1 and Q2. Q2 our final state, so we will make it round. Clear? Q0 is our initial state. So to fill the states here, just move to the transition diagram, and as per the transition information we will fill here. Reading 0 on Q0, it is staying on Q0 only. So we will put here Q0. Then reading 1 on Q0, it is moving to Q1. So Q1. Then reading 0 on Q1, so it is staying in the same state, that is Q1. Reading 1 on Q1, it is moving to Q2 state. Clear? Write Q2. Reading 0 on Q2, so it is staying in the same state, we will write Q2. Reading 1 on Q2, so it is moving to the Q1 state. So this is our Q1. Clear? So this is our final transition table. I hope everybody you understood it. So in this lecture I designed the NFA for the language where the string will contain even number of ones. Clear? I hope you everybody understood it. Still if you have doubt on it, then please mention your doubt in the comment section, so that I will provide the solution for it. So in the next lecture we will come with some different example to design the DFA for the language. Thank you.